Alright guys, today we'll be solving some of the word problems that we have on the review for the midterm. And the first one we're going to do is number 40, and it tells us that we have a person that is standing away from a tree, and the line of sight is 6 feet above the ground, and we are trying to figure out how tall is this tree based on the information that we're given. Okay, so the first thing that we're going to do is draw a picture so that we can get an idea as to what's going on. Okay, so one way we can look at it is that we have a tree here, okay, and we're trying to figure out how tall it is, and a person is looking at it from some distance away, right? This person is here, and they're trying to figure out how tall is this tree. Given the information that the initial angle of elevation is 35 degrees, right? So overall, we can say that this whole distance here from the tree to where the person is originally standing is some measurement x in feet, right? We don't know how far it is. Now, the only thing that we're told is that the person then moves closer to the tree, and it creates perhaps another triangle, and it has an angle of elevation 12 degrees higher than the previous one, so this becomes 47 degrees. So what we can say is that we have two triangles inside of the same problem, okay? And we were trying to figure out then the height of the tree based on the information we're told, right? So from triangle number one, we're going to come up with the following scenario where we have tangent of 47 degrees is equal to, well, tangent is defined as the opposite over the adjacent, and I forgot to put in here that the distance between the first location and the second is 30. Therefore, this is going to be defined as x minus 30. Okay, so we have h, which is the height, as and then the bottom side of the triangle is going to be x minus 30. Okay, now for the second equation, we can say that tangent of 35 is then defined as h over x, which is the longest side, right? So from there, what we're going to do is solve both equations for h. Okay, so that means that number one here is going to be x minus 30 times tangent of 47 equals to h. And then the second equation, this one right here, we multiply the x to the other side, and we have x times tangent of 35 degrees, and that's equals to h. So now that we have both equations equals to h, that means that the height must equal this expression, but also the height equals that expression. So what we can do is set them equal to each other. Okay, so we have x minus 30 times, and let's figure out what is tangent of 47, right? So tangent of 47 is 1.07, so I'm just going to write that in there so I don't have to keep writing tangent 47 all the time. And that is equals to x times tangent of 35, which is 0.700. All right, and I'm just using 2 sig figs or whatever. It's not a problem. So then we're just going to distribute the 1.07 into here, and then we have 30 times 1.07, which gives us 32.1, and this is equal to 0.7x, right? Oops, this one should have had an x. And then we're going to take that away from both sides, and we have negative 32.1 is equal to 0.7 minus 1.07, and we get negative 0.37x, and then we divide both sides by this. So it's the same thing as saying 32.1 divided by 0.37, okay? And we get our x equals to 86.756, okay? But that's not our solution yet, because we're not looking for how far away we were from the tree. We were looking at to see how high the tree is. So we can go back to our equation number 2, where we can plug in this value and figure out the height, right? And this becomes 86.756 times tangent of 35, okay? And we get 60.75 as our height. But remember that the person was looking at it from 6 feet above the ground, right? So our final height has to be increased by 6 units. So if we add 6 to it, we then get 66.75, which becomes 66 or 67, roughly speaking. And that is the solution for that problem. All right, the next problem that we'll do is going to be this one, where the tree is going to cast a shadow of 26 meters when the angle of elevation of the sun is 24 degrees. So we want to again find the height of the tree to the nearest meter. So what we have to do, well, we don't have to, but it's a really good idea to draw a picture. Okay, so here we have our tree, and what it's saying is that we have a shadow. So from the center out here of 26 meters, and then the shadow is going to come from somewhere up there. Okay, now what we're looking for is the height of the tree. So assuming that it goes there from the highest point of the tree, and it has an elevation of 24 degrees. Okay, so this one is very easy, because we can just say that tangent function of 24 degrees is equals to the height over 26, right? The opposite over the adjacent, and then we multiply the 26 over, so we have 26 times tangent of 24, and that equals h. So we can see then 26 times tangent of 24 gives us 11.5 5.7, or we could just say 12 feet or whatever. Okay, or it's not feet but in meters, right? So our solution will be then 11.6 meters. Our units are usually next to the number, and that will be the height. Okay. All right. The next problem we'll do is this one about two hikers that are on opposite sides of a canyon, and each one stands precisely 525 meters above the ground, or above the canyon floor. They each cite a landmark on the canyon and on a line directly between them. Okay, so the angles of depression from each hiker to the landmark are 37 and 21 degrees. Now we're trying to figure out how far away from each other are the two hikers. Okay, so let's do another picture to understand what's going on. So what this is saying is that we have some horizontal distance between two hikers that are looking at a canyon or standing on a canyon. Right, so here we have some horizontal distance, and they are both at the same altitude. Okay, and they are 525 meters above the canyon floor. So again, here hopefully it's the same. Okay, so what we have now is that both are going to be standing here okay, and they are both looking at some landmark here in the canyon. All right, on the floor of the canyon, and I don't know exactly where, but I'm going to call it and say right there, because it doesn't say that it's exactly in the middle between them. Okay, so what's happening is that these people are looking at this directly, right? So their line of sight is directly connected to the landmark. Okay, so that we know so far. Now the problem is that what it's saying is that these people have an angle of depression from their eyesight, or from their sight. Okay, what it means is that this angle and this angle have a measurement of, either one of them can be 37 and then 21. Okay, so that's what we have to be careful on when talking about the angles of depression from each hiker to the landmark are 37 and 21. So this angle is 37, not the inside angle. Okay, so then we can quickly figure out what's the measurement of the angle inside by doing 90 minus 37, which gives us 53 here. Okay, and then same for the other on the right side, where we get 69. So that's very nice. And here, these two angles, if we know, then they're going to be the same angle as that as over here, right? So this is 21 and this is 37. So now we're trying to figure out the total distance, right? So we can say that this is distance A from the hiker to the landmark. Right? And then this is distance B, and not drawn to scale, right? Just trying to give us a visual of what's going on. Okay, so if we're looking at it from the point of view of the hiker, we can say that tangent of 53 degrees, and I'll just make a note. This is my pink one, pink hiker, and then here's my blue hiker, so that we know which equation I'm talking about. Okay, so tangent of 53, right, so it's opposite over adjacent is equal to a over 525, right? And then the equation for my second hiker is going to be that of tangent of 69, and that's equal to the opposite over the adjacent, so b over 525. Now all that I have to do is solve for a and b. So we have 525 times tangent of 53 is equals to distance a, and 525 times tangent of 69 is equals to the distance b. So let's go ahead and do that. And we have 525 times tangent of 53, and we get 696.60, well, 70 equals to a. And then here we have 525 times tangent of 69, and we get 1,367.67, and that's equals to b. But I am trying to figure out the distance between the two hikers, so all I have to do is add this distance to that one, and so total distance is 2,064.4 meters. Okay.